By the end of this lesson, you should be able to use what's called your inverse sine, your inverse cosine, and inverse tangent to find the missing angle of a right triangle. And we're going to use the sides for this. So for inverse sine, you still use opposite over hypotenuse. For inverse cosine, you still use adjacent over hypotenuse. And for inverse tangent, you still use opposite over adjacent. Since let's say the sine of an angle is always the same ratio every time, if we put that ratio into what's called your inverse sine or your inverse cosine, inverse tangent, you will get back whatever angle that has to go with. Okay, so whenever you see to the -1, so if you see there, you see sine to the -1, that means the inverse, okay, the flip. So like if we had the inverse, if you do 1/3 to the -1, you would get 3, because the inverse of 1/3 is 3. So it's using opposites. Okay, so let me show you how you would use like inverse sine. So it's still the one like hypotenuse is labeled, and what else is labeled? The opposite of the angle. And we're trying to find this angle here. We want to know that angle. So we're going to say the inverse sine of opposite over hypotenuse. So 40 over 42. All right, and if we type that in the calculator, if you see I did that over here, okay, make sure your calculator's in degree mode. Don't forget. When I type that, it'll give me the degree of the angle. So that's 72 point, how many decimal places do I go? Let's go 1. So 72.3 degrees. Actually, this should be 0.2, shouldn't it? 72.2 degrees. All right, so 40 over 42 would go with a 72.2 degree angle. Okay, so that's what the degree of that angle have to be in order for that ratio to be there. So right here, again, same sort of problem. This is opposite and hypotenuse. It's the same. This is still sine. So we're going to do inverse sine. Oh, and the way you get inverse sine, I should have told you that. If you look here, here's inverse sine, cosine, and tangent. Okay, so if you hit the functions button and then make sure in Trig, you'll see those there. It'll give you a parenthesis and you'll fill in 11 divided by 27, opposite over hypotenuse, and that'll give you 24.0 degrees. Inverse cosine and inverse tangent work the exact same way. All right, sorry if you guys hear people laughing. The people who live next door to me are having a little bit of fun today, so they're being a little goofy. It's beautiful weather, so that's what you will hear in the background. All right, so inverse cosine. This is used because, again, the hypotenuse label, and what is else? That adjacent side, the side touching the angle I'm trying to find. So inverse cosine, 13 divided by 20. Okay, and when I put that in the calculator, I got 49.5 degrees. This example, again, look, hypotenuse is labeled. What else? The adjacent, so that's why it's inverse cosine. Hypotenuse, whoops, I set that up wrong. Give me that. I already set. Okay. All right, equals, it doesn't equal that. Inverse cosine of adjacent over hypotenuse. When 6 divided by 8, that's going to give me, that would have to be an angle of 41.4 degrees for that ratio to be true. And then inverse tangent, notice on either one of these, the hypotenuse is not labeled. What is labeled is my opposite and adjacent. So inverse tangent, opposite over adjacent, 35.4 degrees. And on this one, again, opposite adjacent, because it's touching that angle. Okay, adjacent means touching, opposite means away from. So again, inverse tangent, opposite over adjacent. I'm going to type that in, I get 23.2 degrees. So angle, that's what the angle has to be. So we're going to find the measure of angle B to the nearest tenth, and so I like to actually mark the angle I'm talking about. I think it's helpful. So we go through the same process that we did with sides. Is the hypotenuse labeled? In this case, it's not. What is labeled is the angle adjacent. Sorry, the side adjacent and the side opposite. So this is going to be inverse tangent, opposite over adjacent. I type that in and it tells me, hey, that has to be a 60.3 degree angle. Example 7. The hypotenuse is labeled. What else? The side adjacent or touching the angle. So hypotenuse and adjacent, that's inverse cosine. Adjacent over hypotenuse. If you accidentally put hypotenuse on top, you get an error, by the way. A tangent won't give you an error if you put the wrong one on top. For cosine and tangent, they know the hypotenuse has to be in the bigger number, so if you put the bigger number on top instead of the bottom, it would get an error. So if you get an error, check that. All right, I get 33.6 degrees. Okay, so inverse cosine, adjacent over hypotenuse, 33.6 degrees. And let's look at this one. Is the hypotenuse labeled? Yes. What the heck is that number? Is that a 30? I'm going to say that's a 30, guys. And then what else is adjacent? Oh, so this is going to be cosine as well. If it was opposite, it would have been if it was opposite, it would have been sine. So adjacent over hypotenuse, and I get 76.5 degrees. So same flow chart. See what's labeled. Use the appropriate inverse function, and then put the two sides as a fraction inside the parentheses, and it'll tell you what angle it should be. So you're going to do the next page, you're going to do the maze. Again, for the mazes, I would like you to write the answers in order that you got them, or just fill in the maze if you can do that. Alright, so if you write this on a separate sheet of paper, make sure you put it in the order that you solved them in.